All right. So starting out, we have f of x is equal to log base 2 of 4 minus x plus 1. Okay, so we are going to start out by finding the domain in interval notation. Remember, you take what's in the argument, which in this case is 4 minus x. Remember, the argument is what is inside the parentheses, and we set it greater than 0. And now we need to solve. We would subtract 4 from both sides, which means that we have negative x greater than negative 4. You could add the x to both sides, but the trick for doing interval notation, where you look at which way the sign's pointing, that only works if your variable is on the left. X is not by itself yet. We still need to divide both sides of our equation by negative 1. But remember, whenever you multiply or divide by a negative, our sign switches. So we're going to have x is less than positive 4. Again, notice that our sign switched. That x less than 4. If you are wanting to do a number line to help you with the interval notation, and maybe not make yours as crazy as I just did, we know that we are going to have our negative infinity on the left, positive infinity on the right, because we get bigger to the right. And the only number that we have in our inequality is 4. So I'm going to put that smack dab in the middle. And this is why I kept the x on the left side, because whenever your x is on the left, our inequality tells us which way to shade. X less than 4. Less tells me to the left, which means that I am going to shade to the left. And that means that my interval notation is going to be negative infinity on up to 4 with a parenthesis. So that means that our domain in interval notation is negative infinity to 4. And remember, it has to be in that order. You cannot switch it up and make it 4 comma negative infinity. It always goes smallest to largest. Our vertical asymptote. Remember, vertical asymptotes are always in the form x equals, and it's whatever number we found in our domain. So we have our vertical asymptote of x equal to 4. Okay. All right, so that means that when we are looking at our graph, there we go. When we are looking at our graph, we can already go ahead and graph our vertical asymptote at x equal to positive 4. And you can even label it because you need to get used to doing that. So we would have x equal to 4, because that is our vertical asymptote. All right. Next step, we need to be able to find 3 ordered pairs for the function. Now, I told you that I was going to use our Desmos graphing calculator in this section. Okay, so if your keyboard is not up, click on the function box, click on your keyboard. If you do not have the ability to type log, you're going to go to functions and all this icky stuff that you don't have to worry about yet. Okay, not all of it is icky, but we're going to scroll down to calculus. You're going to look at log base A. We need a 2. Make sure you press over into the parentheses. We're going to do 4 minus x, close your parenthesis, and plus 1. Even though we can look at this graph to get a visual of what's going on, you still have to be able to graph it by hand. But notice they have a vertical line going on. We get super, super close to it. That's our vertical asymptote, okay, which we just graphed on our graph. But the reason that we put this in is because we can press the gear button and get an XY table. Okay. Yes, you can use an XY table, but you still have to show your work. We're going to pick our values. And if you notice that some of these give us nice values, which is cool. If I plug in 3, I get another nice value. But if I plug in 4, I get undefined. And remember, that's because that's where our vertical asymptote is. So if I'm looking at my XY chart, let's say that we decide to do x equal to 0, 2, and 3. Just for the heck of it. I'm going to insert a table. I don't know why it's doing that. There we go. Insert a table. This will be my XY table. Sorry, my pens are not working very well for me today, which is why I'm typing everything. If you really don't like me typing, let me know. We will work it out for the future. So I need an XY chart. I'm picking the values that give me nice numbers at the end instead of the decimal approximation, but that's up to you on what you want to do. So I know I want to plug in 0, 2, and 3 because those are the X values that give me nice whole numbers for the Y. I still have to show my work on how I am doing these. So let's say that I show my work for X equal to 0 first. Okay. So for X equal to 0, that means I'm taking my function, which we said was log base 2, and instead of 4 minus x, we're going to have 4 minus 0 plus 1. When we plug in 0, calculator tells us that we do get 3. The reason for this is if you do log base 2 of 4 minus 0, that gets us 2. So if you want to do the intermediate step, you can. 2 plus 1 means that we get down to 3. If I were to ask you for the ordered pairs or the coordinates of the points, remember that is x comma y. We just found out that y was 3, which means our ordered pair is 0, 3. still need to do a couple more points. Okay. We said that we would do, oops, try that again. X equal to 2 next. So plugging into our function, that means that we are going to have log base 2 of 4, instead of minus x, we're going to do plus 2, or sorry, minus 2, and then our plus 1. If you want to do the intermediate step, we can. Log base 2 of 4 minus 2 gets us 1. And then we have our plus 1 at the end, which means that we get equal to 2, which means our ordered pair that we just found is 2, 2. Last one. And yes, you will have to show all of your work. That's why we're doing it now. Let's plug in x equal to 3. And we should get a nice whole number again. We're going to have log base 2 of 4 minus 3 plus 1. We know that log of any base of 1 is 0. And we know that 4 minus 3 is 1. So log base 2 of 4 minus 3 gets us 0. We still need the plus 1. So plus 1 at the end, which is how they get the 1. And the ordered pair that we found was 3, 1. All right. So coming back up, I am going to go ahead and put my ordered pairs that we just found. I need one at 0, 3. So 0 and then up 3. Give me a second, I'll get mine out of the way. Change the color, that way you know this is our graph. Okay, so I have 0, 3. I need one at 2, 2. So 2, 2. And then I need another ordered pair at 3, 1. So go to x equal 3, go up 1. There we go. We will need to draw the line connecting these. Remember, as we get close to our vertical asymptote, we're going to get as close as we can without touching. And this time, because, bugger's sake, because we were on our downward descent from left to right, it is plummeting down. This should be as close to the asymptote as you can, but mine's not working there that well. There we go. I did get part of it going. There we go. And then you still have to draw it to the left as well. It's not going to go up like that. It's not a polynomial, it's a logarithmic function. And our logarithmic functions just kind of take their time. Gradually increasing. It's like a little hook that keeps going. Just gradual. Okay, so you can use Desmos to double check or a graphing calculator, but notice that the increase to the left is so gradual. Okay. Let's answer the remaining problems. Notation. Remember, the range is our y values. And in this case, we have a logarithmic function, which means our range is going to be negative infinity to positive infinity. With our log functions, this will always be your range. Always. Okay. Our next step, we need to determine whether our function is increasing or decreasing. And if we look at our graph, scrolling up, remember we read from left to right. If we follow our graph from left to right, we are going down. Since we are going down from left to right, that means that we are decreasing. And then we were asked to graph it, including the asymptote, which we already did. So make sure that you label your asymptote. Ours was x equal to 4, and it is vertical because your log functions will always have vertical asymptotes. And here you can see that our range will be negative infinity and positive infinity because we're going to hit all of the negative y values and eventually all the positive y values. Remember, we will not have anything to the right of x equal to 4 because our domain said that getting close to 4 was as best as we were going to get. So even if I scrolled over as much as I wanted in the graph, it's not going to happen past x equal to 4.